Alright folks, let's talk about something mind-bending today. Venus versus Mercury. These two planets might seem similar at first glance, but they have some pretty stark differences, especially when it comes to temperature. You'd think the closest planet to the Sun, Mercury, would be the hottest, right? Well, you'd be wrong. Despite its proximity to our star, Mercury doesn't hold the title for the hottest planet. Venus is actually the hottest planet in our solar system. Surprising, isn't it? But why is that the case? Let's dive into why this happens. The answer lies in the unique characteristics of Venus's atmosphere and its interaction with solar energy. First off, let's talk about Venus's atmosphere. It's not just any atmosphere, it's a thick, dense one that plays a crucial role in its extreme temperatures. Venus is wrapped in a thick blanket of carbon dioxide, almost 96.5% of its atmosphere. This dense layer is key to understanding why Venus is so hot. This thick atmosphere acts like a thermal blanket, trapping the sun's heat through a process called the greenhouse effect. The greenhouse effect is a natural phenomenon that warms a planet's surface. Imagine a giant greenhouse in space. Just like a greenhouse on Earth traps heat to keep plants warm, Venus's atmosphere traps heat to keep the planet scorching hot. On top of that, Venus has clouds made of sulfuric acid. These clouds are not only toxic but also play a role in the planet's temperature. These clouds reflect sunlight but also keep the heat in, making it even toastier. They act like a double-edged sword, reflecting some solar energy while trapping the rest. The surface temperature of Venus can soar to a scorching 475 degrees Celsius. That's incredibly hot, even for a planet so close to the sun. That's hot enough to melt lead, folks. Imagine trying to survive in such extreme conditions. Now, let's shift gears to Mercury. While it's the closest planet to the sun, its lack of a substantial atmosphere makes a huge difference. Mercury might be closer to the sun, but it has almost no atmosphere to speak of. This lack of atmosphere means it can't trap heat like Venus does. It's got a super thin layer of hydrogen, helium, and oxygen. This thin layer is not enough to create a significant greenhouse effect. Think of it as a flimsy, ineffective blanket that doesn't trap any heat. Without a thick atmosphere, Mercury can't hold on to the sun's warmth. So while Mercury can get incredibly hot, up to about 430 degrees Celsius during the day, it cools off drastically at night. The lack of an atmosphere means there's nothing to keep the heat in. We're talking temperatures plummeting to a bone-chilling minus 180 degrees Celsius. So, what's the result? Mercury experiences extreme temperature fluctuations. While Mercury swings between extreme temperatures, Venus stays consistently scorching hot. This consistency is due to its thick, heat-trapping atmosphere. That thick, heat-trapping atmosphere keeps Venus's temperature sky-high all the time. Pretty fascinating, right? It's amazing how atmospheric composition can influence a planet's climate so drastically. All this just goes to show that being close to the sun isn't the only factor in determining a planet's temperature. The composition and density of a planet's atmosphere play a crucial role. Venus's dense atmosphere makes all the difference. It's a perfect example of how the greenhouse effect can turn a planet into a furnace. If you found this as captivating as I did, make sure to hit that like button and subscribe for more mind-blowing science content. We've got plenty more fascinating topics to explore. And hey, drop a comment below. What other planetary mysteries do you want us to explore next? Your suggestions could be featured in our next video. Until next time, keep looking up and stay curious. The universe is full of wonders waiting to be discovered.